Hi friends, in this video I would like to tell you one problem. So this is the third problem in single phase Halfwave rectifier I have covered so far. So let us discuss what is the problem given first. Later we will go ahead with the solution. A single phase transformer with secondary of 230 volt 50 Hz delivers power to load R is equal to 10 ohm through half-wave controlled rectifier with firing angle 60 degree. Determine rectification efficiency, form factor, voltage ripple factor, transformer utilization factor, and peak inverse voltage. So these are the things we have to find out. Now let's understand the problem. It is a simple transformer is there and secondary is connected to one half-wave controlled rectifier. That means one resistor will be there and it is connected to load R equal to 10 ohm. Okay, it's very simple. So let's see this how we have to deal with it. So rectification efficiency means what is meant by rectification? Rectification means conversion of AC into DC. So how can you get the efficiency? Efficiency is generally output by input. Okay, in practical terms it's simply output by input. So what is output here? Output is simply DC, input is AC. So what is output quantity we need to measure here? Obviously efficiency means generally power efficiency only. So power, so output power is DC power divided by input power is AC power. Very simple. So let's move on to the solution. Yes, so rectification efficiency, so as we know it is efficiency is equal to P DC divided by P AC. So what is P DC then? P DC is equal to V naught average and I naught average. Then what is P AC? P AC means this is V naught RMS and I naught RMS. So here the concept is very simple. RMS voltage and RMS currents are almost same in input and output side. So that's why we are taking RMS. Okay, for AC. Even though we are taking it as at output side only, but RMS voltage and RMS currents are same for output and input. So we are taking RMS at output side so that they are exactly equal to input sides. Okay, so in this way we need to follow. So now let's do slowly, so how we can deal with it. V naught average we need to find out first. So V naught average is equal to, the formula will be Vm by 2 pi. It is half-wave rectifier, so it should be Vm by 2 pi into 1 plus cos alpha. Okay, it's simple R load, so that's why it has come like this. So it will be equal to root 2 into Vs. Vs means 230 volt, it has been given. So 2 is not there, let me remove the 2 here. Divided by 2 pi into 1 plus cos alpha. So cos alpha is 60 degree. So the value will be equal to 77.65. So 77.65 volt. So it can also be written simply such that V naught average into, what is I naught average? Simply V naught average divided by R divided by V naught RMS into V naught RMS divided by R. Okay, so in this way if you go ahead, R will get cancels. Finally it will be V naught average divided by V naught RMS whole square. Okay, finally this will be the thing. So let's move forward. So it's better to find out completely. Okay, so let me find out like this only. So let us go ahead with V naught RMS also. So the formula will be like this: Vm by root 2, Vm by 2 root 2 into pi minus alpha plus sine 2 2 alpha divided by 2 whole power 1 by 2. So which is equal to 230 root 2 by 2 root 2 pi. It is not root 2, it is pi. Okay, 2 root pi into pi minus alpha. Here we need to convert 60 degree into in terms of pi. So 60 degree in terms of pi is 2 pi by 3. Sorry, it is just pi by 3. Yes, pi is 180 degree, so pi by 3 will be 60 degree plus sine 2 alpha, so it should be 120 degree divided by 2 whole power 1 by 2. So please try to use the calculator to get the value, and the value will come around 145.873 volt. volt. And the next one is just the square of this one and this one will come as efficiency. So the efficiency will come around, efficiency will be equal to 0.2834. okay, 0.2834. So if you take percentage of this, then percentage efficiency will come around 28.34 percentage. So I have calculated based on this formula. Okay, square root of V naught average divided by V naught average divided by V naught RMS whole square. Okay, by taking this formula I can go ahead and I have found out the value like this. Okay, you can please check up with your calculators whether it is correct or not. From my side it's correct only. So let me move forward and let us see form factor. So what does it mean by form factor? So form factor is defined as V naught RMS divided by V naught average. So V naught average RMS is 145.873 divided by 77.65, so which is equal to 1.878. so this is the form factor. And the next one is voltage ripple factor. So voltage ripple factor is defined as VRF, voltage ripple factor, and this is form factor is FF, which is equal to square root of FF square minus 1, and this value will come around 1.5908. And the fourth problem is transformer utilization factor. So transformer utilization factor will be equal to V naught average divided by Vs and Is. So Vs is the source voltage and Is is the source current. So V naught average and I naught average it will come around 602.98 divided by Is, source voltage is 230 volt. So we need to take RMS of source voltage only, and source current RMS will be equal to 14.5873 this comes around, this is the I naught RMS only. So since Is is equal to I naught RMS, this part we have already seen, so this factor will be equal to transformer utilization factor 0.1797. okay, so this is the answer. And coming to fifth one, peak inverse voltage. So peak inverse voltage is equal to PIV, you can call it as PIV, is equal to Vm, that is equal to root 2 into Vs, that equal to 230 into root 2 equal to 325.27 volt. So this is very important problem. So it deals with the all electrical things. So that's why it comes as a very important problem in single phase half-wave rectifier. If you have any more doubts, you can ask me in the chat window. And if you like this video, please like it. Please share it with your friends and family, and kindly subscribe to my YouTube channel. Thank you so much.